be discussing about the doubly linked list concept. The doubly linked list is all about you'll be having the head value and the tail value. Head will always refers to the first node of the linked list as what we have discussed in the singly linked list, and the tail will always refers to the last node of the linked list. So this is what we will be doing it. So once you understood the linked list concept properly, then please do take this video, because only then you'll understand how this linked list works, right? So going back to the topic, each and every node will have three parts. One is data, one is next, and one is the previous one. So this is data part that I am referring, this is the previous part that I am referring, and this is the next part that I'm going to refer. Is that clear? So that is what we will understand. Now we will understand how actually it is going to be executed. So here next part will refer to the next node address, previous part will refer to the previous node address. That is what I have given 100 here. That is the reason that I've given 200 here, right? So now you would have understood what is this doubly linked list. So let's move on to the coding part. Before that, we will understand the diagram, complete diagram, how to write the code. So based on that, we will be doing it one after the other, right? So now let us let us go to the diagrammatic part. So now what I'm going to do is we need to understand the node. Okay, so this is the node that I'm going to create. So node will have three parts. One, it is going to be data, which I'm going to store it here, right? So, and the next and previous part, where next and previous is equal to null. So these are the things that we will be doing it in terms of code. Okay, so I told this part is going to be the data part, this part is going to be the next part, and this part is going to be the previous part. So that is what we have. So now what we need to do is we need to understand how to write the code for this. No, so create a class called node. Okay, so inside the class called node, you need to declare three variables. So one is going to be data, which is data is going to be an integer type value. One is going to be node type, which is going to be the previous one. Then the other one is going to be the next one, which is again a node. Okay, so these are the three variables that we will be declaring, right? So moving to the next one, inside this you will be having constructor node. You need to create it. So inside the node, int d, I am going to refer it. So this data, this dot data will be d, this dot next is equal to null, and this dot previous is equal to null. So this is what ultimately we need to do it inside the constructor. Okay, so as a core that we are going to do it. So this d, I am going to store it here, and this null, and I'm going to store it in the left part and right part. So here it is going to be null, here it is going to be null. So this is what I am going to do it. Okay, so these two are nothing but this one and this one. Is that clear? So now we will go to the coding part. So we will understand how to create the node inside the linked list. That is what we are going to do it. So okay, so let's move on to the coding part. So first one is class called node. You're going to create it. So inside this, I am going to have int data node next node previous. So these are the three things that I need to declare, and the constructor, it should be int d. Okay, so inside this I have already given two things. What are they? Which is data, I'm going to store d, and the next is going to be null, right? Is previous is going to be null. So what I'm going to do, this dot data, I'm going to store d, this dot next, I'm going to make it as null, and then this dot previous is equal to null. So these are the three things that you need to declare it. Okay, so once you understand this, we need to create a doubly linked list. For doubly linked list, you need to understand one single diagram. So we will see the diagrammatic part and then we will write the code. So if you need to create a doubly linked list, you need to have one single thing, which is going to be head. If you are going to create an empty linked list, then you need to make head is equal to null. That is what we have done in the singly linked list. So here we need to have two variables. One is going to be head, another one is going to be tail. Okay, so these are the two things. So initially head and tail, I'm going to make it as null. So, sorry, it is disturbing now. So let me move this away. Okay, so once this is completed, then I am going to create a new node and I'm going to insert that here. Okay, so initially let us create a new node. Okay, so initially let us create an empty linked list, then we will create the node one after the other. So for that, what we need to do is we need to create a linked list first, right? So what I'm going to do is I'm going to create a class called linked list, d-linked list. D-linked list is a class that I'm going to create it. So node head is equal to null. Okay, and then node tail is equal to null. Okay, so then public static void main string arguments. Inside this, what I'm going to do is I need to create an object for the linked list. So d-linked list. So let us copy this one, name of the class, and I'm going to create an object. D-list, I'm going to create it is equal to new list. So inside the bracket, I'm not going to do anything. So here whenever an operation has to be done, so we need to create an operation one after the other. So we need to create an operation one after the other. What are the operation we are going to do? We are going to do insertion, we are going to do deletion, we are going to do searching, sorting, traversal, any operation that you need to do it. So here now I'm going to currently use insertion operation in the end of the linked list. This is what I'm going to do it. So for that, what I'm going to do is I'm going to use the object dlist, which I've created, dot insert in end. Okay, this is the operation that I'm going to do. I need to pass a value, right? Because we need to create a node where I need to store the value that node created, which has to be inserted inside the linked list. So that is what ultimately we need to do. So initially I'm going to give 1, and then I should keep on inserting one after the other. So what are the values I'm going to insert? I'm going to insert okay, so 1, and I'm going to insert 2, and I'm going to insert 3, and I'm going to insert 4, right? And then last one, dlist, I need to print it, right? So for printing, traversal is a technique that I told you when we are doing singly linked list, traversal, SAL. So inside the bracket, I'm going to put it this SAL, traversal. All right, so this is what ultimately we are going to do it. Now check this diagram. Each and every node has to going to be created. 1, 2, 3, and 4 is going to be created. Once it is being created, it will be connected anyway to the head and tail, and then we are going to refer to the previous and the next. Depends upon if the node is present, I'll be putting the value. If the node is not present, then I'll be putting it as null. So that is what we will be doing. So now what I'm going to do is I'm going to call this operation, because object is going to be created by this. I need to call this operation. How it is going to be created? Now I need to call this function. Which function? Insert function. This is what I'm going to call it. So void insertion. So I need the data which is passing, no? So D, I'm getting the data from the user. So which is going to be 1, 2, 3, and 4, one after the other. If the function being called, it start inserting, it creates a node and it will be inserting inside the linked list what I've created in the name of D list. Okay. So now what I need to do, first of all, we need to create the node. How you're going to create the node? By creating an object. By creating what object? By creating this one. So use this method. Node, new node is equal to new node of data D. Okay, is that understood? So now what you need to do is you need to create the node, right? So if you need to create the node, go back here. I am going to create a new node. New node is going to be created. Yes, new node is created. Here I'm going to have three things, which is going to be previous and next null. Okay, so now here it is going to be null, here it is going to be null, and here I'm going to insert a value called 1. This is what I have done in the code that I have given here, right? This line is what about the diagram. So we need, since head and tail is equal to null, I need to connect these two things, no? So this has to be connected. If I have some 100 as an address of the first node, then here it should be 100, and the last node, this is the first node, and this is going to be the last node which is being inserted, no? So 100 has to be given here. So two things I need to refer. One is going to be, I am going to store, first I'm going to create it. When head and tail, if it is going to be null, then I can say head will be 100, tail will be 100. So which is head is equal to 100 we have made, tail is equal to 100 we have made. These are the two things we have made. So this I am going to rename by using its name, new node. And here also I'm going to write new node. So this I can write head will be equal to new node and tail will be equal to new node. Is that understood? This is what we are going to write it as a code. Just listen. Going to the compiler, I'm going to check if head will be equal to null, and operator I'm going to use, tail will be equal to null. Then what you can do is head will be equal to, tail will be equal to new node. Is that understood? Or you can write like this also. Remove this, right, add one more line, tail will be equal to new node. Is that understood? So this is what we have done in the diagram. Now what we need to do is, it is all about, we need to when head is not equal to null, we need to insert in the last node. That is what very important, we need to do it. So check this diagram. When head is not equal to null, we need to insert here, right? This last part we need to insert it. So let us take a diagram. I'll explain you very clearly. Okay, so now what I'm going to do is, let us create an head which is going to be 100. Now this is going to be connected to the first node, right? So here it is going to be 1, so 100 is going to be there, and this is going to be connected here. One more node has to be there, which is going to be 2, and one more node is going to be there, which is going to be 3, and this is going to be connected 300, and that is nothing but my tail. So this is going to be connected here, this is going to be connected here, this is going to be connected here, this is 200, this is 300, here it is going to be null, here it is going to be null, and then here it is going to be 200, here it is going to be 100, here it is going to be 300, here it is going to be sorry, this is going to be 300, and This one, it is going to be 200. Okay, so this is what the linked list that I have considered. This is when head is equal to null, tail is equal to null. I made head is equal to new node, tail is equal to new node. When head is not equal to null, this is not equal to null. This is also not equal to null. If both are not equal to null, so else case has to be executed. So this else case has to be executed. So already if the condition is going to be true, then that is going to work. If the condition become false, this is going to work, right? So what I'll be doing, I am going to create the new node. So with this statement we have already written. Okay, for example, I'm going to insert node 4 and I'm going to have 400 as an address that I'm going to insert it. So what I am going to do is I am going to take the reference of the tail. Okay, I'm going to take the reference of the tail. So what I'm going to do is I need to connect this node with this one and this one. So this connection will be terminated. That is what ultimately we are going to do it. Okay, so new node is being created. Just wait for a second. We will understand how this part of the code is going to work. Okay, so now we already know this node is a tail node. Okay, so we'll take the yellow color. This is going to be tail. That is because this address has 300 and that is nothing but the tail node, right? If I say this node, it is going to be head, which is nothing but head is equal to 100. That's the reason this node I'm marking it as 100. So what I'll be doing in the same way, the last node is pointed by the tail. So I am saying last node is a tail node. Now, what I'm going to do is, if I say tail next part is going to be 400, this 400 is going to be stored here, right? This 400 is going to be stored here. At the same time, the new node previous part should be 300 because this node is going to be connected here, this node is going to be connected here. So that is what you will be doing it. So first, initially what we are going to do is I am going to make new node previous part is going to be 300. New node previous part 300 is what? Tail, no? So new node previous part is equal to, I am going to store what? 300. 300 is what? It is what? It is tail, right? So 300, which is nothing but tail, that is what I'm going to do. So here I'm going to refer tail. Okay, so next one, what we need to do is, so what happened, this connection has been established, yes or no? Yes. Next, what I'm going to do is tail next part. Okay, so new node next part, I'm going to mark it as null. So by default it is going to be null. I'm not going to change anything. So now what I'm going to do is tail will be equal to new node, so which is 400. I need to store it here, correct? So tail will be equal to 400. I'll be doing, is that understood? For tail I'm going to store it new 100. So instead of 400 I'm going to write the name of the node, so which is nothing but the new node. Is that clear? Is that clear what I said? Is that understood what you people are clear? Okay, so and then what I'll be doing, 400 is going to be stored here and this gets connected, and then the tail node is being changed. No, new node previous. New node previous is what? This node, correct? New node previous dot next is going to be 400. New node previous dot next. So new node previous is what? 300. 300 next is what? 400. So that is what I'm going to store. 400 is what? New node. Very simple. That is what you are going to do it. Is that clear? So these are the three statements that I'm going to write it. New node dot previous is equal to tail. Tail is equal to new node. New node dot previous dot next is equal to new node. So these are the three connections that we are going to make it happen. So let us go to the else part. Let us go to the else part. So what are the statement that I told? New node dot previous is equal to tail. Okay, this is the first statement. Second statement, tail is equal to new node. This is the second statement. And the last statement is equal to new node dot previous dot next will be equal to new node. Okay, so by that I can able to insert the node inside the last position of the linked list. Is that clear? So if you run the code, you should not face any error. Okay, so let us run the code. Okay, so I didn't give the name. Fine. So let us change the name of the file, which is going to be Java. Please save like this. Okay, so let me run this piece of code. Okay, so execute it. Okay, no error is there. So now actually my code is running. So I need to do traversal. No, from the first till the last node you need to iterate. Same thing, whatever that you have done in the singly linked list, you can use the same thing. So here traversal. Let us do traversal. Traversal is like, okay, so traversal is like you take one node, making first node is a temp node, you will be jumping from one node to another node until temp dot next is equal to null. This is what I'm going to do it. Whatever that we have done in the singly linked list, we're going to use the same code. So void traversal traversal. Inside this I'm going to write the first node, we are going to make it a temp node. So first node, if I need to make it a temp node, okay, let us remove this one. Okay, the first one here, it is going to be 300. Here it is going to be 300. I need to do traversal. First node, we're going to mark it as temp node. Temp. So which is temp is equal to head. This is what you will be doing it, and then you will be printing the value. So while temp not equal to null, SOP statement, temp dot data, temp is equal to temp dot next. Okay, so this is what we'll be doing. Temp is equal to temp dot next. So I'll be iterating to the next position. I'll be able to do it. So temp will move to this particular position, and again temp will be moving to this particular position, so that it will print 1, 2 and 3. So this is what we're going to do it. So just listen to the code. Okay, so if my head will be equal to null, then I can say obviously system dot out dot print inline, inside the bracket I'm going to say d list is empty. Okay, so in the else part, what I'm going to do is, node temp is equal to head. This is what I have done, right? First node we mark it as temp node, and we keep on iterating to the next position while temp not equal to null. So inside this, system dot out dot print ln, not ln, so temp dot data concatenation operation. Let us put an arrow mark so that it goes to the next position. Okay, and then temp is equal to temp dot next. Last temp will be null, so obviously it is going to end. Okay, so let me run the code, and if you see, all the values is being printed. So if you need to print in the reverse order, still you can able to make it. That I am going to make. This part is going to be tail. This part is going to be tail. So here it is going to be previous. Here it is going to be previous. So if I am going to print it, then it will be printing in the reverse order. See? Right, so in the front also I have iterated and then printed, and then the backs also I have iterated and printed. See, here I have changed, instead of head tail, from the last we have printed, from the last one after the other we are printing from the last position. So 4 3 2 1 directly I printed. So reversed of the linked list also I printed in the doubly linked list. Traversal from the front also I have done. So head and tail, both the ways it is working. So we can ensure that both the codes are running successfully. Thank you so much, guys. So in the next session we will understand what has to be done, which is the other part of insertion, another part of deletion operation has to be executed. Is that clear? Thank you so much.